With Mr. C, we are proceeding with the application of the rules for differentiation, and we have got different types of functions that we have. We are going to start with the first one. Given f of x is equal to 4x to the power 5 plus 3x to the power 4 minus 2x3 minus 16x squared plus 20x minus 7. So first step is to check whether it is in the form ax to the power n. Now all these parts are okay. It means it's ready to be differentiated. There's no need to prepare, and the function, it has got f of x, so therefore our derivative will be given by f prime of x is equal to, we drop 5 times 4, this gives us 20x to the power 4 when we subtract 1. The next one, that will be plus 12x to the power 3. The next one would be minus 6x to the power 2. The next one would be minus 32x to the power 1. And then the other one would be plus 20, and the derivative of a constant is 0. So yeah, this is our derivative. So it's done. Now this function is ready to be used in whatever instances that we might need. The next one is the derivative of 2t minus 1, factor of t plus 5 with respect to t. It's not always the case that we have x, so we are working with t. Now there's a problem here, there are brackets, so we must do the preparation first. So we keep on hold, this becomes the derivative of, when we expand that, this becomes 2t times t, this is 2t squared, and then plus 5 times 2, that is 10, plus 10t, and then minus t, and then minus 5. So this is a process of preparing to differentiate, as we said before, by expanding. And then here they are like terms. This is the derivative of 2t squared plus 9t, then minus 5. We are differentiating with respect to t. Take note, we are still taking derivative with respect to t, derivative with respect to t, because we are still preparing. So here we prepared by expanding. Now this is now in the form f of x is equal to ax to the power n. Now we are differentiating. Once we start differentiating, we now say this derivative will now be equal to 2 times 2, this is 4. So that is actually 4t, and then this is plus what? 9. That one is a constant, and it ends here. We no longer write derivative with respect to t. This is the derivative. So here we made use of expansion to prepare, and then we differentiate it. Okay. The next one is very crucial as well. We cannot differentiate because the variable x is on the denominator, but when we look at that, I normally call it the bucket expression. What you need to do, you need to split so that they share. So in this instance, we will have the derivative of 3x squared all over x minus 5x all over x with respect to x. We are preparing to differentiate, but here we have got one term, so we can actually split. This is what we were doing when simplifying algebraic expressions in grade 9. You could split when you are given that. Now this becomes the derivative of 3x squared over x. This is 3x, and then minus 5x over x. This is minus 5 with respect to x. Now this is now one way sorted, so we can now differentiate. The derivative of 3 with respect to x is equal to 3, and then the derivative of the constant minus 5 is 0. So therefore our derivative is equal to 3. So here we have used the split method, and then previously we said here we expand. These are the stages that we use in preparing. Now on the next one, take note, y is equal to x squared minus x minus 6 over 2x plus 3. These are two terms here, unlike here. But if you look at that in this expression, we can make use of factorization. So here we factorize so that we can prepare. During the process of preparing, we keep the y on hold. So we have our y is equal to, I need the two brackets here after factorization. This is all over 2x plus 3. What is the first bracket that we have? 2x plus 3. Okay, that's good. The next one, that would be
X plus 2.
x minus 2. X minus 2. Right. So now you can see that immediately after factorizing, this denominator is going to cancel this part. So our y is simply equal to x minus 2. Our function is now ready to be differentiated. Therefore, notation changes. We are using y. The derivative will be given by dy over dx is equal to the derivative of x is only 1. That is the coefficient. Remember, we have an invisible 1 here, and here it's power 1. So 1 times 1 is 1. X to the power 1 minus 1 is what? 0. And the derivative of minus 2 is 0 because it's a constant. So in other words, the gradient of a tangent and this specific f is equal to 1. So let's proceed. Practice makes perfect. We will have more functions, and this time around we need functions that involve a lot of exponential laws and change of subject. Ta-da!